Hello, this is our presentation on gene clustering, and I'm Cameron.
I'm Nathan.
I'm Sanderson.
I am Den.
All right, you can go to the next slide. All right, so first off, we have a list of known longevity genes, and by using clustering, we can see where the candidate longevity genes get sorted into. These clusters, the clusters with high percentages of longevity genes should have higher credence to candidate genes. For example, a cluster with 9 known longevity genes and 1 candidate gene means that the candidate gene is likely also a longevity gene. So for our data, initially we had 6,000 data points, but we trimmed the data down to 157 data points of the longevity genes and candidate longevity genes. And we ran both k-means and hierarchical clustering on this smaller data set after the normalization. And then this picture on the screen just shows 2 different lists of the candidate genes and the longevity genes.
Yeah, and then we can talk about the code here. Let me share that. All right. So essentially we just have our program from before that we presented on Thursday. Can't remember exactly when, but anyway, all we had to do essentially was take that code and just edit the our data and trim that down. We didn't actually change any of the clustering algorithms because they already worked completely fine. Here's our genes that we're having to go through. We just put them in 2 different lists. And then, let's see. And then here's our little section that we'll take the data and make sure that all the data that we have is only the ones that are in those 2 lists. So that way we can cluster that smaller data set. And then after that, all we do is run what we did before, just the smaller data set. So you can see the original lengths of the 2 groups are 207, but after we remove everything, we have 157 because some of those in that 207 are not in our 6,000 data set. And here's our results from just the console, but we have better results in our slides. So I'll go and reshare that. So here's our findings for the k-means. We can see that for that all the highlighted ones are the known longevity genes. And so we can kind of see which clusters have more longevity genes than others. So we can see cluster 1, it doesn't have very many longevity genes at all. It only has this one. But for, let's see, but for cluster 6, there's quite a few of them. So you would think that the ones that are not highlighted, those are likely to be longevity genes. That's kind of what we were talking about in the introductory slides. And here's just a few more of those clusters. So, and actually cluster 13 had no longevity genes. So we can assume from that that these are probably not longevity genes at all. So for our analysis, like I said already, cluster 13 didn't have any longevity genes. Cluster 2 only had 1 that wasn't a confirmed longevity gene. However, there was only 4 genes in that cluster. And we have our clusters with the majority longevity genes ordered by percentage. So these are the clusters that are most likely to have those candidate genes to be longevity genes. And then the clusters with the lowest percentage of longevity genes are these ones. And the likeliest genes would be in those majority longevity gene clusters, like we already said. And just based on taking the ones that are from 60% or above, it would be these genes right here.
This is the data we have for the hierarchical clustering. Same situation here. These are the longevity genes that are highlighted. No need to explain that too much.
Yeah.
Next slide. And then the analysis of our hierarchical findings. Several clusters only had 1 or 2 data points, which were not really that useful. Cluster 9 had 60 genes, and a majority of our longevity genes Sorry, I read that wrong. And a majority of our longevity genes, but it's only like 51%, 51.6%. Large clusters become less useful, is what that means. Clusters with the majority longevity genes that have more than one gene. These the clusters 8, 7, 9, and 6. You see their percentages there. Clusters with a small percentage of longevity genes was cluster 10. The hierarchical clusters are less useful because there are either two mini clusters with one gene or one big cluster with a lot of genes. Makes the clusters difficult to categorize. Likeliest or unlikeliest genes based on hierarchical clustering.
So overall, k-means clustering provides a good understanding of the data set in which genes are longevity genes. Hierarchical clustering provides a less clear picture of the data set but could still be useful. So k-means is generally better than hierarchical clustering because in hierarchical clustering, we have many clusters which only have one data inside of it, which is not really useful. And that's all we have for the presentation.
All right, thank you.